Okay, so we are recording our lab. So uh, we will continue our lab sessions about design patterns, and we finished creational design patterns in our last lab. And today we're going to talk about structural design patterns. So these type of patterns, they will define the relationship between several classes regarding how they behave, right? So uh, we have 7 design patterns here, and today we will talk about adapter, bridge, and composite. So let's start with adapter. So this pattern is a structural design pattern that allows objects with incompatible interfaces to collaborate, right? Even from the picture, you can see that the car, which cannot go on the rail road, right? Via adapter, it can go. You may make it possible, right? So if we look at the problem, let's say we are working on the application, um, uh, which is basically a stock monitoring application. We are developing such an application, right? So this is our project. So we get the stock data from some provider in XML format, and our application displays this stock data, in a more nicely way, so that you can observe the changes in stock prices uh, and make some decisions, right? So this is your application, and at some point you decided to um, let's say integrate with some third-party analytics library, right? So we can see this uh, library on the right side. But the problem is that this library only works with JSON format, right? Our application and the stock data provider works with XML data format, but analytics library with JSON, right? So how can we solve this problem? So the solution is adapter pattern. So you will parse XML data to JSON in order to integrate your analytics library, right? But this is not so simple, because if you look at the simplest solution, direct solution, we can just write our converter uh, in the following way. That is, we will just create some class, right? Converter, and uh, a method just parses XML data into JSON, right? So by doing so, we may say that we just solved the problem. But unfortunately, this is not the right solution if you want to follow adapter pattern. Why? Because here first of all, adapter pattern, behind the adapter pattern, you may integrate another, let's say, third-party libraries as well. So if we want to follow adapter pattern, we can do something like that. For example, this is the, let's say, example code for adapter pattern. And for example, uh, first of all, you have to create an interface for uh, which, let's say, for your client. So your client only knows the interface, for example, analyzer, right? And this interface should be implemented by concrete adapter, for example, analyzer adapter, which consumes XML data and works with JSON, right? So you in the future, you may introduce another adapters, working with another data formats or with another, let's say, another analytics library and so on. So this is the analyzer adapter, right? And your client only works with analyzer, and he doesn't care about uh, the data format behind it. So this is the, let's say, how you can implement adapter pattern. If we look at the structure of the adapter pattern, so just a second, guys. I'm sorry, I need to answer. Sorry. So um, if we look at the structure of the adapter pattern, so we can uh, draw the overall structure in the following way. So we have, let's say, first of all, of course, we have to introduce some abstraction for our client, right? For example, client interface. And our adapter should implement the methods, right? We delegate the methods to the concrete adapter, and this adapter work uh, with some particular service. So this is how you can integrate with some third-party, let's say, with some third-party applications or libraries into your software, which may not support their data format. So this was about adapter pattern. I hope it was clear. Clear. So you can interrupt me if you have questions. Okay. So let's move to the next pattern. The next pattern is bridge. So this is about splitting some larger classes, or let's say many set. Let's say if you have a lot of classes, and if you have very let's say very deep inheritance level within your project, you can use bridge in order to simplify this complexity. Okay, uh, let's look at this bridge pattern from the problem. For example, you have a shape class. Let's imagine, and you have a subclasses such as circle and square, right? So this is a good solution. This is a good structure, and you want to extend, let's say, you want to add another property, uh, let's say color, and you want to do this by inheritance. You want to implement this, let's say, logic by inheritance. So you plan to create red and blue shape subclasses. Probably, if we look at this picture, we may end up with four, let's say, different classes, different subclasses, if you want to implement another color, right? So red circle, red square, blue circle, blue square, and so on. So the problem of the solution, so we may have another problem. What if we want to add another color, right? So we should create another, let's say, class, or if we want to let's say add another shape, our the number of our classes will be doubled, right? So in this way we're gonna end up with a lot of classes, with infinitive number of classes. So um, inheritance is not always good approach. It depends on the solution, right? So uh, so and the solution could be the bridge pattern. So what is this bridge pattern? So you have to switch from inheritance to object composition. That is, you first of all you have shape class, right? Shape abstract class, and you have circle and square subclasses, right? And you have to separate color, let's say inheritance, to another property. And you should also create abstraction for your color property, such as red, blue, and red. Okay, so shape contains the general class for color, such as color class, right? And your concrete shape classes, such as circle or square, they will contain the concrete color, such as blue, red, and you can easily add another colors. You can easily add another shapes, right, without ending up with many subclasses with right. So this is how you can decrease the level of inheritance. So this is how bridge pattern works, right? If we look at the structure of the bridge pattern, the red module, we can think of them module, they are abstractions, right? So we have, let's say, abstraction. This is the core class. This is the core of the bridge. So it should contain the main logic. You may end up with, you may have some questions. Okay, what class should I make the core? So you have to make the class as core, which holds the main logic, right? So this logic is displayed as abstraction, right? And this abstraction can be further, let's say, extended, right? So with some concrete implementations of abstractions. And we have implementation, let's say, we can say layer in this abstraction, which is for some property, right? That you want to, um, let's say, separate your inheritance to composition, and this will be your property level, and you have to define, you have to declare this property as some abstraction, let's say implementation interface, right? And your concrete implementations, uh, they have to provide some concrete examples of this implementation, and they should have the main logic for the property, right? So this is about bridge pattern. And also, if we look at the real world example, this could be the, I mean, we can think of remote control. For example, we let's say we have if we are working on some project which we have to produce remotes and devices, um, we may declare, or we may define some abstraction for these layers, right? For remote controls and for devices. And the concrete implementations of these layers, such as, for example, for device, you may have radio or TV, right? And each of them have separate remote, right? And in this way, uh, your, let's say, your separate devices can be connected to some, let's say, to some concrete remote, or even you can implement some advanced remote which can handle the let's say all the connections, all the connections, all the connections with your devices. Sorry guys, just a Sorry, I am back. So this is how we can represent breach pattern in real world example, right? So we are now reducing the complexity of inheritance, right, by introducing some abstractions and by separating inheritance into, let's say, composition property. Okay, so this was so let's look at another example of breach. You can think of some cross-platform uh, application as an example of breach. So cross-platform application. If you want to develop some cross-platform application, probably you will build on some cross-platform framework, right? So that this framework will build, let's say, concrete binaries for each platform, let's say for Windows, for Linux, or for Mac, right? So you can think of this as a bridge example, and you may further discuss what is the abstraction layer, what is the implementation layer, what are the concrete implementations and refined abstraction layers, and so on. So this is for you if you want to further discover the bridge aspects, the difference of different aspects of bridge. So this can be also an example for bridge pattern. Okay, as always, you may interrupt me if you have questions. Otherwise, let's move to the next pattern. So the last pattern of today's lab is composite. Uh, so composite pattern is about handling some logic in a tree way. Let's say if you have some complex logic and this and your let's say components or elements can be represented as a tree, you can use composite. How? Let's see this in example. For example, imagine that you are automating or you are working on the process of automation, let's say, of product shipment or product delivery, right? And in the product package part of your project, let's say you have a situation where a package might contain either a product or another box which can also have nested products or nested another packages and so on. So this, let's say, this representation of products can be represented as tree, right? So it starts from top to bottom, and you may think of this as a parent and child nodes. So, and the problem, you might have a problem such as how can we evaluate the overall price of such a package, right? So the condition is that you have to evaluate the price of products, but the packages you cannot evaluate since they contain another product, right? So this is kind of nested logic, and you have to evaluate the price of the all the products in the package. So the one of the possible solutions can be as follows. You just, let's say, unpackage everything from the root package, right? And you will just iterate over products, right? Over products, and you will just sum up their price. But this is not the right solution, since first of all you have to let's say you have to know the type of the element, the child element, whether this is a product or whether this is a box. And even in the unpackaging process, you may have some problems. And the next, let's say, problem might be packaging again these products. Let's in the real world, right? So what you can do, you can just follow composite pattern, which suggests, okay, you have to again implement this, let's say, logic, or solve this problem using some abstraction layer. So we have component interface, right? So uh, your your component interface, which we may think of this as a parent or root node, right? Parent node, and this interface contains the declaration of the main method, such as execute, right? And you may have another subclasses such as leaf and composite. Leaf is the concrete class, right? For example, here there is a description. So leaf implements this execute, let's say, main method, such as price, right? In our case, in the product packagement case, and our composite, also known as container, you can call this as parent, another parent. It will just delegate the execute method to its children, since this composite holds only children, right? It doesn't whenever execute is called on this particular composite, it will just delegate this execute into its children, right? So this is a recursion. So if we look at the code snippet, how we can write some code in for such a structure. First of all, okay, we are in Java. We can declare some item interface, right? And for our case, the main method is price, right? So we have an interface item with the method of price. Our main element, let's say core element, such as product in our case, it will just contain, it will implement this method and return its price, right? Since it knows its price. And your, let's say, box, which is a parent node, right? It will just call, and whenever price is called, it will just call its children's price, and in the end, it will return the summed up price. So this is how you can implement a composite pattern. So this is basically recursion in, let's say, in programming, but the main difference is that you have to pay attention to this interface. Okay, if we want to follow the let's say standard composite pattern, you have to introduce let's say interface and do the logic through the interface. So this was about our composite pattern. I hope it was clear. And if you have questions, please ask. Otherwise, we will move to the problems. So I hope everything is clear, guys. So let's move to the problems. And the first problem is, this is a problem of, let's say, vehicles. Let's imagine that there are many types of vehicles, right? Such as cars, bus, vehicle, motorbike. You can introduce another types. Your task is to create a structure which allows you to create a workshop which produces and assembles cars. So you have to apply bridge pattern design, bridge design pattern, and you have to draw UML, and we will discuss your solution. So guys, please start working on this exercise. If you have questions, please ask. So after, let's say 15 minutes, I may ask from anybody of you. Okay, not to disturb you, I'll turn off my mic and camera. I think Aidar wants to say something, right, Aidar?
I just wanted to say I'm done.
Okay, so you can share your work with us, please.
Okay. Can you see the screen?
Yes, we see your results.
So in this task, we had different types of vehicle, cars, bus, and so on, and we have to create a structure for workshop which produce and assemble cars. So here is the diagram. We have an interface vehicle which has method assemble, and we have three concrete classes: car, bus, and for example helicopter, which implement this interface. So they have method assemble, and then we have the workshop, which contains a vehicle in it. So if a client wants to create workshop which assembles, for example, cars, client should uh, uh, initiate workshop with vehicle set to car. So that's it.
So here you have implemented bridge pattern, right?
Yes, bridge pattern.
Okay. Okay, so vehicle workshop. But I think, can you also extend your workshop further?
Uh, yes,
Yeah,
we can, but I don't know for like what to extend, what to add to it. It's
maybe you can create a concrete workshop for car, for bus, or for
but
helicopter.
that's the point of this bridge pattern, that we do not create concrete vehicles. We avoid inheritance and use composition instead of it. So to create workshop for cars, we create just this workshop and set vehicle to car.
Yes, I got it. So I was thinking maybe your logic contains two directional some property. Now I see that you just decrease the complexity of workshop, right?
Yes,
Before
yes.
it might be car workshop, bus workshop, or helicopter, but now you defined with vehicle.
Mm.
Yes, I see. Yes, yeah, you can do it. And just a second, uh, let me note. Yes. Thank you, Aidar, for your solution. So thank you. Yes. So if anyone is ready, you are welcome.
Can I also show my implementation?
Yes,
It is a
please.
bit different.
Yes, please. Let's see.
So I decided to apply the same kind of strategy as we did in lecture. And in lecture, there was like separation between implementation and abstraction. So I decided that I will have like abstract class for vehicle, and there will be like concrete classes, car and bus, that will extend from vehicle. and as an implementation part will be by interface vehicle implementation, and there will be so concrete implementations for car and for cars and buses. And I decided that vehicle, it is like a high level abstraction, so it will contain some information about vehicles like number of seats or model. And as for methods, there will be some general methods to know some additional information like color or is this vehicle registered. And for implementation, exactly, it is responsible for assembling and or changing or upgrading vehicles, like interface like assemble upgrade. And in client there will be like make order or do this particular vehicle, some sort of methods. So this should be also like correct, right?
Yes, but it would be better if you have another dimension for your vehicle implementation. So just a second. So I mean, you have car implementation and bus implementation, right? So so car and bus, they are the concrete cars, right? I mean vehicles. And vehicle implement. Okay, so here you decrease the complexity of vehicle types and vehicle implementations, right?
Yes.
So otherwise you may end up with, I don't know, okay, car implementation. Okay, so okay, can you please repeat this? What does this vehicle implementation do? This is for production.
This is to separate like implementation of a vehicle, like how it is produced, like how it is assembled or upgraded.
I see. Okay. Now it makes sense. Yes. Thank you, Marina, for your solution.
Okay.
I will also
Can I
note.
also show my one?
Yes, sure, please.
Yeah, I'm not completely sure in it, and that's why I just want you to ask if it's correct. So, can you see my screen?
Yes.
So I have a workshop, which is the abstraction. In this case, it has some general actions like upgrade vehicle, prepare vehicle, some set vehicle or get vehicle in case we want to like put another car to the workshop to change some parts and so on. And we have the interface vehicle, which has, for example, get wheels, get engine, get body, get transmission. And for each type of, for example, vehicle, like bus, sport car, or casual car, you have different implementation, like with different wheels, different engines, different bodies, and different transmissions. So this is it. Did I get it correctly?
Yes. This is correct, since you decrease the complexity. Otherwise, you may end up with more number of classes, right? For example, workshop for bus, for I don't know, for sport car and for casual car. Yes, this is correct, and it's like either solution, and so this is correct. So if you have another, let's say, complexity levels, you can also introduce these complexity inheritance by properties. I mean, so, but this is also correct. So you decrease one dimensional, let's say, complexity, but in the example, we also saw two-dimensional, two-dimensional, let's say, complexity within our project, right? So
Mhm.
this is you also decrease the complexity, and this is we can consider this as correct. Thank you, Mikhail.
Thank you.
So let me also note. Okay, so if if someone is ready, you are welcome to present your work, guys.
I can present what I did.
Yes, please, Rajkumar.
Okay. Yeah, so this is what I have. So like the clients, like we have the workshop that can either produce or assemble, and the interface is very vehicle. So depending on like maybe for example the color of the vehicle or the grade, like ABC, it can be a truck, a car, a bus, and uh, yeah. So like the bridge is the abstraction workshop and interface vehicle.
Mhm. So this is yes, yes. So um, you decrease complexity. Yes, I see. Otherwise, you would have workshop vehicle for car, workshop vehicle
Yeah,
for bus, right?
yeah,
Yes. So okay. So the same comment. I mean, this is a one-dimensional. Your how to say, it was a one-dimensional logic, and you decreased it. And we saw two-dimensional, right? For example, here you have color. You may also introduce another dimension such as engine, right? Engine types for small or medium or for large, and you can also implement that engine logic via properties. So, so that it would be two-dimensional. But still, this is a correct. We can think that implementation of bridge. Thank you, Aziona, for your solution. I will also note you, and I think we have enough uh, solutions for problem one. And let me introduce the second problem. I hope you already read it. So the second problem is about applying adaptive design pattern. So let's say you have only Type C ports in your laptop, right? And let's say, first of all, you have a smartphone with USB output, and you want to connect your smartphone to your laptop. And the second, let's say, case, or the secondly, is that you have to connect a projector with HDMI output to your use Type C laptop, right? So your task is to apply adapter design pattern following the structure, right? And show your UML diagram. So please start working on this task, guys.
Yes, I can show.
Yes, please, Lev.
Are you showing?
Yes, I was setting up. Now it should be visible. In a while. Is it visible? It's not visible to me yet.
Yes, it's visible.
Yeah, okay. Now it's visible. So yeah, it's not much here, but well, essentially most of this code is not representable by UML. Basically, what we have here, we have a laptop with a method which can connect a device which conforms to the Type-C device interface. This is this interface here. However, the devices that we have, they implement these two interfaces, and they cannot be directly passed here to this method. So, in order to remedy this, we are defining two classes, Type A to Type C and HDMI to Type C, which both accept a Type A and HDMI device, respectively, in the constructor, and the resulting class implements the Type C interface. So essentially, if we were to show it in code, I guess I can just do it like that. Let's say we have an object of type laptop. Give me a second to do it like this. Yeah. So say we have a laptop L, and can I please have a cursor? And we have a projector of HDMI device. Then, in order to connect the projector to the laptop, we would first wrap it in a in an HDMI to Type C adapter projector. And this argument can now be passed to the connect device method since it implements the Type-C interface. And that's what this accepts. So yeah, that's the gist.
So here, your client is laptop, right?
Yeah.
Okay, so your client, and your interface is Type C device, and Type to C, Type to
Type
C
A to
your.
type.
And you can connect Type to C. This is adapter, right? Type A.
These two classes are adapters. Let me put them in blue.
Okay.
The blue classes are adapters. The orange ones are interfaces, and the green one is the client.
Type C device, Type A device. And are these interfaces interfaces for adapters or for devices?
What do you mean? These interfaces are just interfaces,
Okay.
and they can be implemented both by devices and by adapters.
Yes. And which, I mean, can you show the connection between your laptop and between your adapters? It's just one arrow.
Well, yeah, I guess it would be just an arrow use as follows. So a laptop would use the adapter. Well, it doesn't necessarily have to use it. It's rather that in the client code, it can be used.
Okay.
So laptop directly doesn't use this adapter, but this adapter can help. Yeah, that's why I was saying that it's somewhat hard to represent this in UML, because these things, they are supposed to happen like kind of in between. in between the laptop and the projector, and is best representable by actual snippets of code.
Your projector.
So if we were to show what a projector is a class that implements this HDMI device interface.
Okay.
So a projector is a particular object that implements HDMI device, which means we can pass it to the constructor of HDMI to Type-C right here. And then this object is going to start implementing Type-C device, which means that can now be passed to connect device of laptop.
Okay, so so you are representing projector through HDMI device, right?
Yeah, projector implements HDMI device.
Okay, I got it. So yes, I see that there is an adapter, but if we look at the structure of the adapter pattern, can you show us the structure if it's easy? I mean, you have to represent your adapter through some interfaces.
Well, yeah, I guess I could write like a couple of methods here. Well, let's just write it down below in text. So let's say send with Type-C. This is going to be a name of the method. Like this. This is a method of, why are you doing this? This is a method of Type-C device. Then Type-A device would be, for example, send with Type-A. And then we would say that Type-A to Type-C implements a public method, send with Type-C. So in this sense, we can see how Type-A implements the Type-C device interface. Oh, I mean, this class implements the Type-C device interface.
Okay, so here you want to say that Type-C device is an abstraction for Type-A to Type-C, right?
No, Type-C device is an abstraction for Type-C devices. Type-A to Type-C is an adapter that accepts on creation a Type-A device and exposes this method, which internally uses this device to convert between the two connection types.
Okay, so your adapter is Type-A to Type-C, right?
Yes.
Then if we want to follow, of course, you are free to, let's say, implement the adapter depending on your needs, on your situation. But if we want to follow strictly to the structure of the adapter, where is your interface? Where is your abstraction to your adapter layer? You get me, right? So Type-A to Type-C, these are the concrete, let's say, adapters, and we have to, we need to have some abstraction which our laptop will connect to.
Yeah, this abstraction is type. Oh yeah, maybe this is where this arrow should be, the use arrow. The laptop uses this interface.
Okay, so the arrow should be opposite then.
Why? Oh, right. It's the laptop that uses this interface. And now we can see how these adapters can help use a projector by the laptop.
Now I see. Now it makes sense. Okay, it was. Thank you, but still, it was your representation. I think it is clear for everyone else. We discussed a lot about adapter, and let me know.
I want to show my solution.
Yes, please, Natalia. I have not left.
Okay. Can you see something?
No, we can't see it.
Not yet. Okay, and now?
Yes, we can see.
Okay, so this is my implementation of the adapter pattern. So we have some client here, but actually just a person who uses a laptop or some other like party, the third party who uses a laptop class. We have a laptop class that supports Type-C connection. And for this, like to connect something to it, it uses connect function, which returns nothing but accepts a Type-C adapter. And Type-C adapter is an adapter interface. And if we use plain Type-C like cable, it will be just like Type-C class, like with Type-C connector and Type-C connector type. However, as we know, we have only USB adapters, so there is a USB adapter class, which which has a public field Type-C. Oh, by the way, it shouldn't be void; it should be Type-C adapter. Okay, like this. We have USB adapter class, which has a public Type-C field, which makes it the adapter class, and private USB field. USB field is referred to the USB class. And can you hear me?
Yes, yes, we can
Okay,
hear.
and USB field is private because we do not want to USB connection, like, well, we want to connect some cable using USB connection. However, we do not want to know that it is USB connection, so we must hide it. And to make it, we use the function connect, which accepts as an argument USB class and returns a Type-C adapter. And then the laptop uses, if we want to use USB thing, we just like get the Type-C class like this.
I see. So here your adapter is USB adapter, right?
Yeah.
And Type-C and USB, they are some devices, as I
Yeah,
understand.
there are some devices.
Now I see. So for Type-C, you do not need any adapter. You just connect.
Yeah, but we want to be it uniform, so so
Uh-huh.
we inherit like Type-C is a subclass. Like it implements interface Type-C adapter because otherwise we should write like several functions.
I see. I got it. I got it. Yeah, it makes sense. Makes sense. Thank you, Natalia, for your solution.
Okay.
And I have also notes.
Okay, have I stopped the sharing?
Yes, thank you. Thank you, Natalia, for your solution. And if someone is ready, please let me know. And let me ask other people as well. Okay, so we have here Mohammed, right? Can you hear me?
Yes, I can. I'm sorry, I'm not ready.
You're not ready?
No.
Okay. So what about Big John? Okay, Big John is not available. What about Daniel? And what about Marina? Marina Ivanova.
Yeah, 1 second. I need to connect from laptop.
Okay, no problem.
So, okay, I think I can show you.
Yes, please.
Yeah. So, here it is. I have my laptop with Type-C. Its interface with the method to connect using Type-C. And also have a smartphone with similar method connect, but using the USB connector, and projector with HDMI connector, and adapters between them with corresponding adapters. Is it visible?
Yes, yes. So here your concrete adapters are adapter type C to USB and adapter type C to HDMI, right?
Yeah.
So your laptop here interface is kind of abstraction for adapter levels.
Exactly.
I see. So and they connect to some device. Yes. So this is a, I mean, correct implementation of adapter. Thank you, Marina, for your solution.
Thank you.
And let me also note you as well. So guys, if anyone is ready, please let me know. And but our problems are over. I mean, we can finish our lab. If you have some questions, please let me know, and I will be here for a few minutes in case if you want to discuss something. And thank you for your participation.
Thank you. Goodbye.
Bye. Goodbye.
Thank you.
Uh, uh,
Yes, yes, Oziama,
yeah,
we are here.
I had a question. Like, I just, like, for the adapter, can I share my screen, please?
Yes, sure.
Okay. Yeah, so this is what I have, and I noticed it's kind of different. I didn't know, like, should there be, like, the class for laptop that also um, is used by the adapter? Because, like, I thought the client interface itself, like, the client interface isn't it the laptop? Because, like, other devices are trying to connect to it, or
Better to have a relationship which client interface uses adapter. So I think this is more correct since your your laptop uses some adapter, right? Right? You connect you connect some adapter to your laptop so that your laptop through that adapter connects to other devices. So this is the first comment. And the next is you try to kind of generalize devices, right? I mean, you have
Yeah.
some. So okay, so and you can just make the arrow from adapter
Mm-hmm.
touching to device. I mean, yes.
Ah.
So this, yeah, and you can leave this box
Mm-hmm.
which represents some generalization for your devices. You can leave, and we may think, okay, so this is a module for devices.
Mm-hmm.
So this is fine, and that's all. And your, let's say you uh, and your client interface, it represents your some laptop or something
Yeah.
like that,
Yeah.
right?
Yes.
Okay, then that's fine. That's fine. Yes, sure.
Okay then. Thank you.
You're welcome.
Okay. Goodbye.
Bye. Bye. Okay, thank you guys, Big John and Daniel. Can you hear me? Our lab is over, so if you have some questions, please let me know. Otherwise, you can email me.